Git, a distributed source control repository. I try to picture clusters of information as they move through the file system. Were the commit messages like history books? I kept dreaming of a repository I thought I'd never see. And then, one day, Git real.
You're watching Git Real, and this is level 2, where we're going to be talking about staging and remotes. So let's say you're in your local repo and you made a change to a file, but you don't remember what that change was, like, for example, the license file here. To figure out what that change was, you can run the git diff command. You're going to see here that it's going to show you unstaged differences since the last commit. In the red, you can see the line that was removed, and in the green, the line that was added. Now, diffs here in the command line aren't that understandable. Luckily, there are tools to make it easier to read, which we'll go over in the outro at the very end. But let's go ahead and add that license file to our stage. Once we've added it to our stage, if we run git diff again, well, nothing's going to print out because there's no differences since all the changes have been staged. If we do want to get a diff on all of our stage changes, we can run git diff -- staged, and we'll get the same output that we did before. So if we do git status right now, we're going to see that we have that one license file that's staged and ready to get committed. But what if we stage stuff that we didn't mean to get staged? Because keep in mind, you might have a lot of modified files, and you might want to take, 2 of them and do them on one commit, and take 2 more files and do on the next commit. So how do we get things off the stage? Well, you'll notice in this git status output, it says use git reset head and then the file name to unstage. Then when we run the command, you can see it says that we unstaged license. You might be wondering what that head command is there. Well, head refers to our last commit on the current branch or timeline that we're on. Now, if we run git status, we're going to see that the license file is not on the stage, but it still has its modifications. But what if we change our mind and we don't want those modifications? What if we want to reset it to the state that that file was in at the last commit, or the last time it was changed? Well, we can do that by doing git checkout -- and then the file name. So if we do that and we run git status again, we're going to see that the file has been restored to its previous state. Now let's go ahead and make a change to the README, talking about how the cake is a lie. If we wanted to commit this change, we'd have to add it and then commit it. Well, there's a shortcut. We can run git commit -a-m in the commit message. What this is going to do is going to add any of our tracked files to the stage and then commit them. Now, the caveat here is that it's not going to add any files that we're not tracking. So if I had created a new file and ran this command, well, it's not going to be included in the commit. There's going to be a time when you're running Git where you're going to make a commit, and then you're going to instantly regret it because you probably forgot to add a file or make some sort of modification that you wanted to be included. How do you deal with that? Luckily, we have this git reset command you see here, which will undo the last commit and move everything from that commit back into staging. So that head command you see there with the little caret, what that's saying is move to the commit one before the current head. So now if we run git status, you can see that our changes from that commit are now staged. I can make changes, add files if I want to, and recommit. Another way to modify commit is to use the amend option. So if we wanted to add that to-do.txt file to our last commit, we could simply add it to the stage and then do git commit -- amend, which is going to add it to the last commit. And then if we want, we can even specify a new commit message, which is going to overwrite our previous commit message. Here are the 2 commands we just went over. You've got git reset, which will roll back the last commit, and then you have git commit amend, which will add things to the last commit. There's 2 more that you should know about. If you want to do git reset hardhead, that's going to blow away the last commit. So if you just went horribly wrong and you just want to blow it away, you run hardhead. And then if you want to undo the last commits, well, you just add another caret onto the end. So that's saying blow away the last 2 commits before the current head. So up until now, we've been working with just our own local repository on our computer, but how do we push that repository up to other people so they can contribute to it? Well, that's where the push and pull command comes in. So here I am in my local master. I can push that to a remote repository, and then other people can pull that repository down and start making changes. And then when they're done, they can push back up their changes. When we're dealing with remote repositories, it's all about the git remote command, which we'll be going into in a minute. The other thing worth mentioning is that Git doesn't take care of access control for you. It doesn't allow you to say, just these people have access to this repository and just this group of people have access to this one. That's where you're going to need some additional software. You either might want to use a hosted solution like GitHub or Bitbucket, so they take care of access control for you, or if you want to roll your own, you can use something like Gitosis or Gitorious, and they take care of access control and all that configuration. If we wanted to store our repository on GitHub, we would create a GitHub account, and then we'd create a new repository on GitHub. It would give us a form that looks like this. We would specify a name of that repository and specify a couple options. Then once we create it, GitHub is going to give us a URL. To push to GitHub, we're first going to have to run git remote add origin. Origin is the name of the remote. We could give it any name, but usually we'd refer to our canonical repository, our official repository that most of our people are using for our project as origin. So origin is what we're going to call it, and then we specify the URL that GitHub gave us. To get a list of all the remotes that our local Git repository knows about, we can simply run git remote-v. Now, we haven't actually pushed our repository. These remotes are kind of like bookmarks, right? We're just bookmarking that this origin refers to this URL, and we might have multiple repos. Now, if we want to push our repository, we simply run git push, specify the remote repository name, which of course is origin, and the local branch we want to push there, which is master. Since we're using GitHub, it's going to ask for our GitHub username and password to authorize us to push to the GitHub remote. Now, if you don't want to have to enter in your username and password every time you push, you're going to want to follow this link down here at the bottom, which talks about password caching, so you only have to do it once. So we've pushed our local repository up to GitHub, and now if we go back into our browser and refresh, we're going to see that GitHub now knows about our repository and all the data in it. On this page, you'll notice there's a commit button, also a history button. If we click those, we actually get the same information that we got previously from Git log. We can view all the different commits inside our repo. So we've pushed our repo up to GitHub, but how do we pull it down? How do we pull down from a remote? Well, that's where the git pull command comes in. That's what you're going to want to run when you know that other people have made changes. You're not the only person working on the project, and you want to get their changes. You run git pull. It will go up to GitHub. It'll pull down your changes and sync up your local repository. So we have GitHub as our canonical remote called origin, but it's not uncommon to have multiple remotes with a project. We might have a test server that runs our tests for us that we occasionally want to push our repo over there. We might have a hosting provider that has our production code in it, and we might want to push our repo onto our production server so it can host the code. As we saw before, to add a new remote, use this syntax, git remote add, specify a name, it can be any name, and then the address. To remove remotes, we simply do git remote rm and then the name. And lastly, to push our repository to remotes, we run git push-u and specify the name and the branch. Now you might be wondering what this -u option does. Basically it makes it so that next time you run git push, you don't have to specify the name and the branch. You can just run git push. Lastly, I want to talk about Heroku, a hosting platform, and the way they use remotes. So if you have a Heroku account and you install the Heroku gem, and you're working on your code, and you type Heroku create, you can see it does a couple things for you, one of which is gives you a Git repo SSH address. Now before, we were using a URL. GitHub gave us a URL. Well, a lot of times when you're working with Git repos, you might instead have a SSH address. As you can see here, Heroku already added a remote for us. It called the remote Heroku. And now if we want to push our code to Heroku, we simply write git push Heroku master. That's going to push our local repository to Heroku. And when Heroku gets the code, well, it's going to deploy it. One last thing before we finish level 2. Remember these commands where you can roll back commits, blow away commits? Well, you only want to run them before you've pushed those commits, right? Because if you have some commits and you push and then you change them locally, it's kind of like you're changing history. And as we all know, that's a very dangerous thing. So don't do it. It's time for you to get into the challenges and get real once again.